So today's presentation is going to be about buoyancy. So the textbook definition of buoyancy is the ability or tendency to float in water or air or some other fluid. Now, looking aside from the textbook, this means that everyday objects are almost constantly being submerged into some kind of fluid and are undergoing some kind of buoyancy force. Now, this will vary based on the object and based on the fluid. For example, I'm sitting right now in my chair making this video. There are buoyant forces from the air. Because they have such little effect, they're practically negligible. Now, if I were to jump into a duck pond, or an ocean, or a lake, the water would push me up at such a higher force that the buoyant force would be noticeable. Now, looking into what composes the buoyant force, well, the buoyant force is proportional to the volume of the fluid displaced by the object, as well as the density of the fluid itself. So you have a density of air and a density of water because density and buoyant force are proportional, and water has a much higher density than air. Chances are the buoyant forces from the water will be greater than the air. Now this allows for some objects to sink or float, and you can even get levitation when talking about uh, air. Who discovered this concept, you may ask? Well, it was actually a man named Archimedes who was living in Greece and was trying to figure out if king's crowns were made of actual gold or were counterfeit. And he was trying to do so in such a manner without damaging the crown. And while he was taking a bath, he shouted, "Eureka!" and realized the flotation of some objects compared to others were different. Some objects would sink in the tub, and some objects would float. Now, he discovered that buoyancy was the reason for this. He also proclaimed that it was due to an object being submerged in water experiences a greater pressure due to the weight above it, making the increase in pressure levels eventually lead to a larger buoyant force. And he also said that the more dense of a fluid, the better chance an object will float. So Archimedes' principle is everything Archimedes discovered bundled up into one paragraph, and it says, a body at rest in a fluid is acted upon by a force pushing upward called the buoyant force, which is equal to the weight of the fluid that the body completely displaces. If the body is completely submerged, the volume of the fluid displaced is equal to the volume of the body. Now, when looking at this from a sheer equation standpoint, we see that a buoyant force is equal to the density of the fluid, obviously, and the volume, but it's also equal to the gravitational pull, or F buoyancy equals PGV. Now, when we apply this to balloons, which will be our test subjects, we realize that a balloon filled with air will not float due to the fact that uh, although the volume it displaces is the same, the weight of the air um, would require more volume displacement or more dense fluid in order for the balloon to float. However, when an object is filled with helium, it experiences an upward force since it displaces enough air to be greater than the weight of the helium inside the balloon. So when we apply buoyancy to balloons, we can use a free body diagram to see which components we need to look at. So if I want to make my dog float with balloons, we need to look at the components of all the up arrows and all the down arrows. In this case, the down arrows are going to be the weight of each object, the helium, and the dog itself. The dog being the most predominantly heavy object, all having to equal the buoyancy force if I want it to be at equilibrium. Obviously, if I want the dog to fly, I could just chuck on a bunch of balloons and just say that F buoyancy is greater, but we're trying to keep it as close to equilibrium as possible. Now, although the balloons I was using, were not perfectly spherical, or not perfectly spherical. Yeah, we're gonna assume so. That way the math is more friendly. So when I was calculating the amount of balloons it would be for to make my dog float, I realized that the mass of the dog would equal the dog system would just equal the volume and displacement of all the balloons times the density of air. Earth's gravitational pull canceled out of that equation. But I realized that, it would one balloon would only be a fraction of the 11.33 kilograms that my dog weighs. So I realized that if I'm using 24-inch balloons, which are ginormous, it would cost hundreds of dollars and take hours to complete. It would not be practical. So I decided to use a less heavy test subject like Gilbert the goldfish. Now Gilbert, fresh out of PetSmart, weighs about 1.5 ounces compared to the dog's 25 pounds. So I was tempted to make the goldfish float balloons. I did go through my struggles. It was a little easier because it was 6.1 ounces instead of 25 pounds, but I realized that I originally wanted to try 9-inch balloons, and I was going to do many little balloons. But it was clear that not only did this like waste a lot of my budget that I had, uh, it wasn't effect like we were piling on weight from the balloons so quickly that it just wasn't effective. What was effective, however, was resorting to that same 24-inch balloon and using it, but only using like a few, because they store so much helium inside of them, and they only weigh about zero point 0.4 ounces per balloon, which is quite heavy per balloon, but they're able to lift a quite substantial amount compared to that. The challenge here, like I previously said, we're actually making the balloons like be at that equilibrium point, as opposed to them just floating in the air. Because if anyone can just throw a bunch of balloons onto a bag of goldfish and make it float in the air, right? But the hard part was like trying to calculate how many balloons. I got between 3 and 4 in my calculations, and in my experiment, it took three. It took three to keep it at a pretty nice equilibrium. See, we got the before, we got the after, uh, floating in my living room. I have a video of me floating around Gilbert the goldfish. You can see that it's staying at equilibrium, but it's still going down. I didn't get the math perfectly correct. Yeah. So oh, look at Gilbert swimming in his home. So to summarize, to to summarize, buoyancy. Buoyancy is the phenomena of an upward force experienced by an object submerged in fluid. Examples of this are water and air, as discussed. It is led by Archimedes' principle, which states that the buoyant force is directly related to the volume of fluid displaced by the object multiplied by the density of the surrounding fluid. After this experiment, obviously I'm not going to harm the goldfish or dispose of the goldfish in any way, but instead I have a pet goldfish named Gilbert, and Gilbert has a home.